Okay, so anyway, like I said, you guys wrote this down yesterday. And we talked about how when there's a compound that's made via bonding, that if we tried to take those two things that made the compound back apart, they are not going to look the same. In a mixture, though, we learned yesterday, when we pull the things out, they still will look the same. Even if it's a salt solution, we could boil off the water and we'd have salt left, and we could, separate then the water off from that by capturing the vapor and cooling it back down. Okay, but compounds, that won't work. What kind of chemical compound is water? What kind of bond do we have? Because they're doing this with the electrons. Say it loud.
Covalent.
Yeah, it's a covalent. And so we got, this is our covalent bond. So again, it's a compound. The thing about this, when we try to pull the hydrogens and the oxygens away from each other, this is what happens. We already said water was polar and that the oxygen tries to hog the electrons. Well, when the hydrogen tries to pull away, the electron immediately gets sucked into the oxygen, and we get a hydrogen that loses that electron. So we end up with a hydrogen ion that is positive, and so that's one part of our water reaction. We get hydrogen ions. Okay, on the flip side, that electron goes with the other hydrogen and the oxygen, which stay together, and they pick up the extra electron and become more negative. And this is a new word, hydrogen's easy, but we get a hydroxide ion. Okay? Now, why is this important? Well, we said water was important. Why, guys? Why is water important to us? Jacob? It's part of our body. It's everything. It's pretty much all of life. It's how much of the world? 3/4 of the world, and hence why we're called the blue planet. We even talked about today in my honors class, I said, we were asking why questions. I'm like, I'm not sure. I don't know why. I said, why is the sky blue? And I said, oh, but I do know that. It's because we're the blue planet, and most of what the water that we have is reflected up into the gases up there, and so our atmosphere appears to be blue. But if it's a kind of a cloudy, gloomy day, is our atmosphere like blue? It's more gray sometimes, right? It's kind of crazy. Or when we're bringing in a lot of water, it turns really dark blue because we're bringing in more water, right? So nonetheless, hence the blue. But this is important because when we go to test things in our everyday life, and we talked about yesterday, I asked you about I think I did, how many of you guys have pools or hot tubs or know people that use these pH strips to test their water? Raise your hand. Quite a few of you. Okay, how many of you have never used one of these before? Raise your hand. Well, that's a good thing because now you're going to get to use them and you're going to have fun. Tuesday, we're going to do a lab and we're going to hit the ground running. But today, we're going to figure out how do we get what we've got on here? What does this mean? Okay? So, today's lesson is regarding using this, remembering this when we break it down. It's regarding the pH scale. Here's what I want you to do. Don't write down what's in the picture, but I want you to write down everything else. So write it down, and then I will talk to you about what you just wrote down. Okay? 2 lefties in here. Maybe more. Can't tell if you're typing. I see 2 lefties. Interesting. Do you slap or do you just regular bat? Do you slap bat or do you regular bat? Regular.
What is even that?
What's that?
What is even that?
Slapping?
What is even that?
It's different. Baseball doesn't have it. Slap batting is basically where you're on the left hand side, which is weird for me because I'm not left, I'm right. But anyway, you like run at it and you hit it and then you can keep going. You already have the momentum.
Is that even allowed?
Yeah, in softball.
I'd regular hit it, break your head up.
So like when you're up to bat, you run at it?
Yep.
Yeah, you don't stand here and bat. You actually like run at the pitch.
That would go to the moon. That's not fair.
A lot easier.
It's a thing in softball. Yeah.
I can hit it way harder.
But you do it left. You do it on the left side. You don't slap from the right side. You slap from the left.
That's just running to third base.
Sorry, got a little off tangent, but I just saw people riding. I was like, ooh, how many lefties do we have? Reagan's a lefty, so I always just noticed that. She's the only lefty in, well, not in our whole family, but in our immediate family. Okay, guys, so the little p up here in pH represents like parts per. Parts per. And the big H, what do you think that represents? The hydrogen ions. So pH is saying how many hydrogen ions or how much or what's the amount of or what's the concentration of, you can say it all those different ways, how many hydrogen ions are in a mixture or solution, suspension, what have you. Okay, we've got some ranges here. So I want you to write this out. This is why I didn't want you to write out this one, because I will tell you, this 0 to 14 is typical range for our acid, base, and neutral. However, the ones we're going to use for our lab next week, they only go 1 to 12. So you're going to see sometimes variations on different pH testers or indicators, but no, in general, it usually can range from 0 to 14. There might be a few other swimming pool type pH testers that might even go up a little higher in numbers. But for everyday acid, base, neutral, it's 0 to 14. So on your paper, I want you to write this. Okay? I want you to write a 0, a 7, and a 14. So we're going to write this out so it makes sense. And again, you wrote it out just now, but I want to kind of put it in a scale that makes sense. Okay, at the 0, under the 0, I want you to write acid. Under the 7, I want you to write neutral. And under the 14, I want you to write 2 words. Base, and the word is alkaline. They mean the same thing. If a substance is a base, it's also an alkaline. Or you could say it's basic or alkaline. Okay, I'm going to go ahead and write the ranges that you can see up here. For acids, sorry Isaac, I'm trying to smash this because I know it's got to be hard to see over there. All right, acid, the pH range is 0 to 6. So if it is a 0 to a 6, it's going to be an acid. Neutral is only the 7. And base or alkaline are 8 to 14. Okay, so if I say, all right, something has a pH value of 9, you're going to say it's
Base alkaline.
basic or alkaline. If I say it's a pH of 2, you're going to say it's an acid. And 7 is always neutral. And there's only one neutral. 6 and 8 are not neutral. They are weak acids and weak bases. So again, 7 is just neutral. All right, however, the whole point of the pH scale is to measure the amount of hydrogen ions. To me, I feel like whoever made this, like, it just didn't make sense to me. Because if I was measuring something and I had more of them, I would think I'd give it a higher number. Like, the more I have, the higher number. But this person, whoever came up with this, or people, they came up with more like a winner. If you have more of something, you're the winner, you're number 1. Okay, they kind of came up with it like that. That's the best way of me putting it. So, we're going to remember, the more hydrogen ions you have, the more acidic you are, the lower your number. So, I'm going to write this up here. I'm going to put H positive, meaning my hydrogen ions, and then I'm going to put a plus sign. And then I'm gonna put a sign that goes like this to negative, meaning there's more numbers, all right, and then there's less. So there's more hydrogen ions when it's an acid and a lower number. There's less hydrogen ions as we go up the scale and get bigger numbers. So in acids, there's more hydrogen ions. Okay, does that make sense? Okay, at the bottom, I'm going to do the hydroxide ions. We're not necessarily measuring them, but if you ever see a question about hydroxide ions, it's opposite of, obviously, the hydrogen ions. So there's going to be more hydroxide ions over here, so I'll put some pluses over here. And as you go towards acids, there's less of those, right? Does that make sense? So, let me ask you this question. I know you're writing, which is awesome. If I tell you that there is 2 pHs given, there's an 8 and a 6, and I say, which one has more hydrogen ions? What are you going to say? 6. 6. Make sense? Now, what if I told you this? Give me the pH where there's equal hydrogen ions and hydroxide ions. What are you going to say? 7. Neutral. Okay? Does that make sense? Good guy. Good. Every year on the test questions, this is one that trips people up. So I like to kind of do it different than just looking at the scale and writing it like that, because I feel like that helps you look at all the possibilities. The hydroxide ions, the hydrogen ions, the base and acid ranges, and of course, strong acid, strong base. The stronger the acid, the more hydrogen ions, the lower the number. The stronger the base, the bigger the number, the less hydrogen ions they have. Okay, are we all good? Okay, so before we move on, I want to show you a couple of tests, because you guys told me that you've not been able to utilize the strips, and you can buy them, I think, at Walmart. And I'm going to show you, if you can't get to these, I'm going to show you a natural method of making a pH indicator, which we're also going to use next week. All right, so I want to show you first. Okay, I've got just a regular tap water that I was using yesterday. And when you guys use these strips, when you open up the little tube, you'll see that there's lots of strips in here, okay? But they are kind of expensive, so I try to use them cost efficiently. And I tear them up into tiny little strips, kind of like this. I actually tore them into like 8 little strips like this, because when you do your lab next week, you're going to use the forceps to dip it, and you're going to have these little trays that have little wells in them, and you're just going to dip the solution. And then what you're going to do is you're going to take your paper and you're going to compare it to the bottle here. And what's on the bottle are numbers aligned with certain colors. So whatever color that it turns is the number that you will utilize for that solution. So I'm going to use a little bit bigger one, because I'm going to dip it. I'm going to tear it off here. And I want you guys to tell me the reading when I come around. So this is, again, our tap water straight from our tap here at school. So let's bring it so I can dip it. Ooh, it's a close one. All right, the thing about this, after you dip it, leave it in there for about 2 seconds, and then you want to go about 5 seconds, okay? 5 seconds at the max, and read it. So you guys can look and see what number you think it is, okay? And then we're going to talk about what number should it be, since it's water. And we just broke down our water in the water reaction. And we're supposed to be measuring, part of water, right? The hydrogen ions. Now, one thing I will tell you, the longer this sets, the darker sometimes it tends to get. So you've got to read it after the 5 seconds, because if you don't, then you might get a false reading, okay? You want to be pretty quick about your read, because it can get darker. But you guys are going to get to do this on your own with different solutions that you get to choose from with the ones that I have. Okay, all together, we're gonna, on the count of 3, say what do you think it was. Ready? 1, 2, 3. 7 or neutral. Yeah. And is that a good thing for water? Yes. It is a very good thing for water because it should be neutral because water is broken down into 2 parts. Equal parts, right? So we should be neutral. Now, over the years, I've done a study of water. And I bought certain types of water, and I'm going to put this up on the screen. But before I do, like, some of you probably don't even drink water. I know I've had a few of those. But how many, like, you drink bottled water? And a lot of you are going to say, well, I drink bottled water, whatever mom brings home or whoever brings home. But think about what type of bottled water you drink. Get it in your head, and we'll see if it's up there and see if it's a good water for you or if maybe you should think about not drinking that kind of water. Okay, so let me put it up. Give me just a second.
My dad buys different water like every week.
It's ice now.
Water's water.
I drink mainly Dasani.
Okay, so I know it might be a little hard to see, but here, now I will tell you, I bought at Kroger in 2017 when I started here the first year at Indian Creek after being at Franklin for a while. I bought all these waters, and on that particular day, I put down how much that particular bottle of water cost me when I bought it at Kroger, and I put how much it was, but to make it easy to compare, I then calculated how much it was per liter to buy that water, okay? So I did this for a reason so people could see, number one, the pH, what were good waters, which we hope is what number again? 7. All right, and again, then for a price per liter, like what is your best buy with your best water, and then what was like your worst buy? So as you can see, I have Avion, I have Core, Dasani, Aquafina, Life, Propel, Just Water, Simple Truth, Kroger brand, Perrier, Fiji, Ice Mountain, Cleanse by Balance, Smart, Simple Truth, Italian Water, Coconut Water, Nestle, and then I did these last year, but I forgot to put them up there, which is just the Walmart, Great Value. Just the Basics, I believe, is like the Lowe's generic brand, and then Members Mark is Sam's Club. And then I did some people's, like mine, and some people's water who brought their own water in. If you guys want to bring in water that you haven't drank out of already, because that'll mess up the results, bring some next week, and we can test those too. That's always kind of fun just to see what your house water is. I have well water at my house, and you can see my tap was an 8. So my tap is a little bit more basic, but then I also have like a little filter on the side of my sink that filters it under the sink, and it took it to a 6. So I'm like, shouldn't the filter like take it to the normal? But it didn't. It like took it to the other side. So I guess if I mix my 2 waters together, I could have a nice 7. But I don't even think about doing that most of the time. But anybody out there drink Aquafina? Was in your head? That is the worst water for you to drink as far as it's way acidic. Look at that. It's a 5. And if you go for how much it costs for that particular day, it was $3.02 per liter. Crazy. Yes, Isaac.
The reason some of them are slightly low on the pH scale is because like some spring water has minerals in it, and some of them add fruit like lemon and stuff like that.
Very good. Yes. And all of these, with the exception of, I believe, the Italian water, honestly, and the coconut water, these were all just plain water. But you're right. Different minerals coming from different places. Definitely, like, you're going to have all kinds of different acidities. You'll notice that most of them were more acidic instead of basic, with the exception of, like, Mrs. Davis. She lives in Bloomington, and her tap water was also 8. So our tap water, mine's a well. I don't know about hers. I think she said it was like Bloomington's water, the Monroe County, but I'm not sure. But yeah, I mean, most everything you see is acidic. And so it's kind of, and when we do our lab, you're going to see just how many things are acidic that you use in your everyday life. It's crazy. And we wonder why, like, we have so much upset stomach and stuff like that, because we have a lot of acidic stuff. So, in my first period class the other day, I was at Walmart and I saw this, and I was like, oh, cool. This is a water, but it straight up tells you it's supposed to be alkaline water, and it's supposed to have a pH of 9.5. So 9.5, just so everybody knows, 9.5 will set between right here, between those two. So it should be like a green, dark blue. So if it's 9.5, that's the color it should come out to, right? Let's check it out. All right, so get a little water here. I'm gonna put it in the thing again. That one. All right, here we go. You ready for it? 2 seconds. Bring it out. I won't walk it around this time. I'll just bring it over to someone. But do you think it's getting dark blue or green? Lies and deceit. Fellas, tell them what number it is. Wait, top number.
6.
Yeah. It's pure acid. Not pure, but it's definitely an acid. It's nowhere near the green, blue at all. It's right there. It's close to a 6, even heading to a 5. So they're marketing this as alkaline 9.5 pH. Why would somebody want to buy a water like this? Like, if they thought it was basic, why do you think they'd want to buy something that they thought was basic to begin with? Help what? Health? What about it? Maybe. You might be right. Did you know that your normal stomach is acid, right? You have acid. The acid helps to digest your food and break down things. Your mouth even has an acidic nature to it. So sometimes when people get upset stomachs, they might have more acid in their stomach and it's got overzealous, right? And then they have acid reflux. They just will feel terrible. So maybe if they felt like their stomach was too acidic, maybe they'd buy something like this to try to really throw some basic in there. But it's going to make it worse because we just did the test, and this is the 3rd test I did today, and every single time it's come out a 6. So it's acid, and they're saying it's almost a strong base. Yeah, so not good, right? Quick question for you. How many of you guys, when you do have an upset stomach, you prefer to maybe take Tums or Pepto-Bismol or eat crackers or something like that? Raise your hand if that's kind of how you deal with your upset stomach.
I drink ginger ale.
Okay. All right. I'm getting ready to ask. How many of you, when you have an upset stomach, you would prefer to drink Sprite or ginger ale, 7-Up, eat some chicken noodle soup? Okay. Last year I had a co-teacher with me, and you guys probably remember Roman played football. His dad was in here, and he told me that when he has an upset stomach, he would like to eat pickles and fried chicken.
Oh, that's normal.
Okay? And we're going to figure out, like, when we do our test next week, like, what is pickles and fried chicken? Like, where would they fall on that pH scale? And maybe, depending on, his stomach, why that was helping him. So, if you think about it, Pepto-Bismol, Tums, and crackers are all things that have more of a basic nature to them. Where the ginger ale and the Sprite and the chicken noodle soup are more acidic. So those of you who usually have upset stomachs, it might be like because you're too much acid or too much base, and by eating or drinking those certain things, it helps to bring it back. And when you do stuff like that, that's what our next slide is. Let me put it up here if it'll let me. Okay, maybe not. It's this, a buffer. Okay? And it's our last slide. Okay? Buffer is a weak acid or a weak base that might help prevent a sudden sharp change, like for strong acids and strong base. So we already said your stomach is acidic. But if you get too much acid in there, you might want to take something like the Tums, okay, that will help you bring your stomach back to its normal pH. You don't want a super duper duper strong base. You just want something very weak just to kind of bring it back. Or vice versa, maybe you might get Alka-Seltzer, and this is one I have not tested yet. But I'm wondering if maybe that might be the other version of this is a weak acid that would bring it back if it got too basic and you needed to bring it back up to the acidic pH. I'm going to try to buy some Alka-Seltzer because that's one I've not tested, and I want to make sure we test it because I've not done that. And every year I say I'm going to do it, and then I always forget to get it. And one year I remembered, and then they didn't have any when I went to the store. Go figure. All right. But anyway, there's another word up here. And do you guys know what the word homeostasis means or what it is? Anybody have an idea? Everybody's still writing it down. I'll give you a second. We're almost done. I know. It's been one of those Fridays. The good news is you're not going to have homework when you leave, so yay. Okay. So, in your home, hence the name homeostasis, okay, and stay, think home, stay. In your home, you have this thing that allows you to maintain a constant, steady temperature. Anybody know what that's called? A thermostat. And so let's say you set the thermostat on 68 degrees. And so what happens? If you set the thermostat on 68 degrees, what happens? Okay, it gets to average temperature. I heard somebody say something over here.
It becomes 68 degrees.
All right. Well, your heater or your air condition are going to run until the room temperature becomes 68 degrees. And then once it hits 68 degrees, it does what? Turns off. But then, lo and behold, it goes up to 70. It shoots up to 70. So what happens? It kicks back on to try to maintain that certain temperature. Okay, that's what homeostasis is. Homeostasis is trying to maintain a certain environment. I'm going to call it that. In your body, that's your temperature, 98.6. That might be your water value that makes up your body. Your electrolyte, okay? Atmospheric pressure is something that's out there that might be something we try to maintain a certain amount of, okay? But homeostasis is maintaining that balance. So you may want to write that down, that homeostasis is maintaining a balance of a specific environment. And then you can write down things like your temperature, your water, your pH, right? So I will tell you right now, I know we're battling the virus, right? We're battling the virus, but always this time of year because you guys are coming from your summer off where you were able to stay outside longer or maybe inside longer, whatever your choice is. I know at my house we're outside a lot more longer. And then all of a sudden now you're having to go to school and you're in a cold building all day. And then when you leave, what happens when you leave and walk outside the door? It hits you like a ton of bricks. It's really hot. And then some of you stay outside doing chores or doing activities, and so you get even hotter. And so if you're like me, you see I usually wear a sweatshirt or a sweater because I'm kind of cold in here, and I'm trying to help my body stay warm. I don't want it to have to be working all the time and me shivering, because me shivering is my body trying to produce heat to keep my body warm. Okay? I don't want to go outside, and leave my sweatshirt on. I'm going to take my sweatshirt off and just have my t-shirt on or whatever, so that I'm not going outside and I'm sweating to death trying to cool my body down. All right? When you don't do that, and kids don't do that. Kids do whatever. And so you stand here and freeze, and then you go outside and then you're hot. And so while your body's doing this, up and down, it's trying to heat itself up and cool itself down. And meanwhile, because it's working so hard to do all of that, you're opening the door for the little germs to come in. And that's why people tend to get sick during the change of the seasons. Couple that with, you guys aren't used to sitting in a classroom all day. You're outside doing your own thing. You're having to work harder. You're getting less sleep because you're doing homework, or maybe you're doing after school activities, or what have you, or maybe you're working a job, or you're having to go home and do chores, but you are getting tired, and you may not be eating right. Hopefully you are, but I know my family, we don't always eat the best every day because we are so go. So because you're not keeping a maintained balance, of rest and temperature and food and water, okay, and probably vitamins, okay? Your body is always working to try to keep you there, to maintain homeostasis. And then in the meantime, people get sick. And it's unfortunate, but it's true. So I always tell people, and I just got through telling the volleyball team that this last night, that you need to try to stay on top of that if you can. Make sure you're helping your body stay warm and cold. That's an easy one. Okay, try to drink plenty of water because that helps fuel your metabolism and keep you well balanced. Okay, try to eat right, and if you can, get plenty of sleep. Like you really should try, even though you probably have a lot of stuff going on. But anyway, if you do that, that'll help fight off any other viruses or germs, bacteria that's out there that try to sneak in and get you. So, anyway, I hope you learned something today that was new to you. On Monday, we are going, not Monday, nope, you're going to be at home having fun, right? I'll still be here probably doing some stuff, but nonetheless, Tuesday, we're going to come and we are going to test some of these solutions. But I want to show you one other thing before you head out of here, and that was my homemade tester. So if you can't get your hands on a Hydrogen paper tester, you can do something really cool. You can buy some red cabbage. It's about 68 cents a pound at Walmart. Okay, it's just a little head of cabbage. I put about 4 or 5 leaves and I put them in some water and I boiled it and I bought some Q-tips and I threw the Q-tips in there. And these guys act as testers. Now, they don't always have the exact same colors as a pH Hydrogen paper, but they do turn some cool colors. So here is an acid, and I'll show you. Again, this is what it looked like to begin with. It was just purple. But when I dip it in this acid, look what color it changes. And it's just from simple cabbage juice. Right? Theoretically, if I put it in this one should turn a green color, but I know that's not going to happen, but let's check it out anyway. Nope, just stayed purple. So, again, that is definitely not what we hoped it to be. Anyway, we're going to use the cabbage juice indicators, we're going to use pH paper, and we're going to have some fun trying to figure out some pH values. Please bring some water from home if you'd like to, and we can test your water and add it to my chart. Okay? You guys have any questions?